Hello friends, we are going to study Thevenin's theorem. Whenever find out the response either current or voltage when the load resistor will be changing, then every time we have to calculate. Then we are going to find out one method in which whenever load resistance will change, then we need not to calculate many times. Only one equation will be enough. Coming to the topic Thevenin's theorem, let us assume we have one complex circuit. And we are taking the response across any particular element. We can name as RL. So if we want to calculate the response IL or VL, we have to apply few methods, that is your nodal analysis or mesh analysis or KVL or KCL. But whenever you want to calculate this value of RL, then every time you have to calculate. Then we want to find out one method so that our calculation could be minimized. So what we will do, we can represent this into an composite circuit across your load resistor. So composite network or circuit. And here is your load resistor RL. This composite network can be converted into practical voltage source. Then that will be considered as Thevenin's theorem. And if this composite network is converted into practical current source, then this would be your Norton's theorem. Right now we are studying practical voltage source, then it is your Thevenin's theorem. So we can express this composite network into your practical voltage source. It means there would have one voltage VTH and RTH across your load. Now you can easily calculate the value of I or V every time value of RL is changing. So from here the calculation would be very easy, but to find out this internal circuit, this composite network is little bit difficult. So now we are going to focus on how to calculate the value of VTH and how to calculate the value of RTH. In any linear bilateral electrical circuit containing voltage source and current sources can be replaced by a practical voltage source, that is your Thevenin's theorem. Our main target is to find out the value of VTH and RTH. To find out the value of VTH, we have to only open the terminal. Like if this is your load resistor RL, and this is the point A and this is the point B, and this is your internal circuit. So what we have to do is only we will just open this terminal AB and we can find out the value of VOC or VTH. This is how we can calculate the value of VTH through your nodal analysis, your mesh analysis, your KVL or KCL. While calculating the value of RTH, it is very important to look in the circuit, whether circuit consisting of only independent sources or dependent sources. If there would be only independent sources, case number 1, when circuit consists only independent sources. Then the first point is we will represent the voltage source by its internal resistance, that is ideal. So the internal value of ideal voltage source will be equal to R internal of ideal voltage source is equal to 0. Then if there is any voltage source present, then that would be represented into short circuit like this. This is plus minus, and if we are finding out the RTH, then this will be like this. Same current source can be converted into its equivalent resistance of ideal current source. The ideal current source have internal resistance equal to infinity. So infinity means open circuit, means whenever there is a current source present in the circuit, it would be represented as open circuit while finding out the value of RTH. Case 2, when we will be having both sources, independent as well as dependent. So it would be very tricky. What we will do as previous, when we are having independent sources, independent voltage source, then it would be converted into short circuit. Independent current source, it would be converted into open circuit. And we cannot short circuit or open circuit the dependent voltage source or dependent current source. We will leave as it is, and across the terminal, let us assume this is your composite network and this was the terminal AB, and we will put one voltage here V and the current flowing I. Then the ratio of V by I will be equal to RTH in case of dependent voltage source or dependent current source. Thank you.